MTD Network are visiting Rotec Engineering in Evesham. Now, we're doing this because they're always at the forefront of technology, investing to keep ahead of the game. Now, Ollie, what have you gone and done? Nakamura?
Never Nakamura, I'm afraid.
Why?
They're just really good, versatile machine. There's not really a lot that I can do on this machine.
A lot you can do or can't do?
Well, a lot I can do.
So, when you say Nakamura, I'm thinking precision, quality, powerful, rigid.
Yeah, everything in there, everything, yeah.
Okay. So, what's in terms of axes, how many axes has this machine got?
So we have got essentially a 5-axis mill turn machine.
Right.
Just got one B-axis milling spindle head. Makes it very easy to program because you've only got one bit going on at the same time. We've got a large magazine capacity on it. We've got 80 on this machine.
80 tools?
80 tools.
So if you're running a lot, I mean, we'll talk about the robot arm in a minute, but if you're running a lot of parts, and you could double tool basically?
Double it, triple it, whatever you fancy really. You could fill it full of rough turn tools and go forever really.
Brilliant. So you're making, I mean, give me an idea of what sort of parts you're making on this.
Again, we're doing a lot of sort of complex sort of 5-axis turn parts. Before now we would do a lot of it, sort of turn the blank parts out and then maybe put it on our 5-axis machines and mill it out that way. Whereas on this machine we can just do it all in one go and it's just a one-hit wonder.
Nice.
Parts go in, finished parts come out.
Nice and simple, and again, doing it one op, essentially, keeping that accuracy, consistency.
Yeah. Yeah.
Which you get anyway with an Nakamura, but just doing it in one op. Also, the observant among us would have seen a robot arm in the background. How is that helping with this machine itself?
Again, we can just get more production, and we're always trying to run on a bit of a skeleton crew, trying to find people who, with skills nowadays, is getting more and more tricky to find. And the skilled guys don't want to stand there running a machine. They want to get the machine up and running and go on to the next one.
Yeah, you don't want to be loading billets all day long.
You don't want to be loading billets all day, no.
You want to be using your highly honed engineering skills.
Yeah.
So how easy though is this to load, operate, program?
It couldn't be more simple. It's literally a few questions that it will ask you. What type of part you're putting on, so essentially on a lathe we'd be putting round parts on there, but not restricted to round parts. What diameter it will be, say 50 mil, putting 50 mil, the length of it, 100 mil, 100 mil, and that's the operating side of the robot setup. And then next thing you need to know is your jaw setup, so how far the jaws are sticking out. Yep. And how much step you've got in the jaws, and that is essentially the robot ready to go.
You make it sound really, really simple. In fact, hopefully you might encourage some engineers to get in, well, some people to get into engineering, because, I mean, you're making some real quality complex parts, but you make them in what sounds like a relatively straightforward and simple way.
Yeah, I mean, the key to anything is just try and keep it simple, and that's exactly what they've done with the robot, and what we try and do with our parts anyway. Yeah. We make something really quite complex, but try and do it in the most simplistic, easy, quickest way of getting it going.
Ollie, great endorsement of Rotec, of automation, and investing to keep ahead of the game. Thank you very much.